Okay, in this video, we'll look at angles of elevation and depression. It's really just language to help describe situations that we can then apply our trigonometry tools to. So the setup is a side-on view of a story, and imagine we're standing here. Now, I'm just using a janky eyeball to represent us because in these stories, we're often looking at or observing something. And this is the most important part. We start by thinking about a line of sight going straight across the horizontal. If from this horizontal we look up at something, the top of a building or a tree or a cliff or spotting a plane or something, we call this angle going up from horizontal an angle of elevation. If from the horizontal we look down at something, maybe this time we're standing at the top of the building and looking down at something on the ground, or we're at the top of a cliff and spotting dolphins or something, we call this angle going down from horizontal an angle of depression. And again, the most important thing is that these angles are always measured from horizontal. Elevation goes up, depression goes down, but honestly, even that doesn't matter as much as just understanding that we build these angles from the horizontal, from a line of sight going straight across from left to right. So here's a quick example of this in action. It says an owl is 7 meters above ground in a tree. There's a mouse at an angle of depression of 32 degrees, because this owl is special, it knows numbers. And we're asked for how far the owl needs to fly in a straight line to catch this mouse, who is presumably already dead or paralyzed. So let's draw a quick picture. When we draw these pictures, keep it simple. So don't draw an actual tree with leaves and stuff, just draw the information that's important. So there's an owl at a height of 7 meters above ground here. It sees a mouse somewhere on the ground, and the angle of depression is 32 degrees. Now, before we can even think of drawing the angle of depression, we need to draw in a horizontal from this owl. By far the biggest mistake I see is just plonking the 32 degrees in between the brown and the pink line or something, but that wouldn't be right because the brown's a vertical line. It's going up and down, not across. So we've got to draw this horizontal here to begin with, and only then can the owl look down from this horizontal. And that angle is 32 degrees. And now we need to find the flying distance, so the pink length here, which I'll mark as x. And now there are several ways of solving this from here. You could use the 32 degree angle by imagining the 7 moving across this way and working in this right angled triangle. But for the purpose of stuff we'll do later, I think it's good to start being comfortable just playing with the angles in a picture to get what we want. And so if we aim to just use this right angled triangle we've already got here, we can notice that the horizontal up top is parallel to the horizontal down the bottom. So if you cast your mind back to like year 7 angles, you might recognize this zigzag pattern here, meaning the 32 degree angle is exactly the same as the one down here in the triangle. And now before we move on, we might notice the symmetry here. The 32 degree angle is now the angle at which the mouse would be looking up from his horizontal to gaze into his murderer's face, meaning 32 is actually the angle of elevation from the mouse to the owl. They're both being measured from horizontal. And that's why I said before that the most important thing about these angles of elevation and depression isn't even which one goes up and which one goes down, right? That's also just quite easy to remember from the names themselves, but the important thing is they must go from horizontal, and I can't stress that enough, okay? Even if you get the up and down wrong, the numbers are meant to be equal anyway, so it won't matter all that much. But let's move on. The x we're after is the hypotenuse, and the 7 is the opposite, right? It's opposite the 32 degree angle, so we use a sine. We feed it the 32 degree angle. It gives us a fraction for opposite over hypotenuse, so 7 over x. And so we might recognize that the division symmetry is helpful to use here, where x and sine 32 can switch places. And punching 7 over sine 32 into a calculator gives 13.2 meters. And so that's what angles of elevation and depression are. They're angles measured up or down from horizontal. And once you've got a good picture of what that looks like, it's often just applying our trig tools to the right angled triangles that pop out. That's all for this one. Thanks for watching. See you next time.